So we want to look at some questions here where we've got an equation of a line. So, well, it's an equation, it's an inequality really, but it's related to the equation of the line y is equal to x plus 3. So like we've done before, we're going to graph that line. So find our intercepts, graph it through, so it's going through minus 3 and 3. So there's our equation there's our graph of our line. So graph your line up normally. It's equal to, so notice it's solid, there's no gaps there. Now, we test 0, 0. So if we put 0 into it, 0 less than or greater than or equal to 0 plus 3, that fails. That's not right. So it can't, 0, 0 doesn't satisfy it. So 0, 0 is not in the half that we want. So we go to the other side of the line. So that's why that part is shaded. So that, again, notice the technique we're using. Graph our line. Notice if it's shaded or solid or not solid, and then shade whatever side 0, 0 is, whether it's if it satisfies the equation inequality, shade that side. If not, shade the other side. Let's try x y is equal to less than or equal to x minus 2. So again, we graph y is equal to x minus 2. So it's pretty easy. Pick 2 points, graph your line up. It's equal to, so notice it's a solid line. And then we pick 0, 0, and so 0 less than or equal to 0 minus 2. Now 0 is not less than or equal to minus 2, so it fails. 0, 0 is not in the region, so shade the other side of the region. So this time, y is less than 2x minus 4. We've graphed 2x minus 4. Notice, and it might be a little bit hard with this one, but it is dotted. So it's a dotted line there, going through 2 and going through 4 there. So we find our x and y intercepts pretty easily by subbing in x equals 0 for the y-intercept, y equals 0 for the x-intercept. And then test 0, 0, and we'll see that 0 is not less than 0 minus 4. So it fails, so it must be on the other, we shade the other side. This side gets shaded. This time, graph y is equal to 3x minus 6. So again, we graph it up, we go through 2, we go through 6, minus 6 here, and it's not shaded, so it's not equal to, so we don't make the line solid. We have a dashed dotted line there, or a dashed line there. We test 0 this time, so we have 0 greater than 3 lots of 0 minus 6. Now this time it does work. 0 is greater than minus 6. Which means that 0, 0 is inside our region, so we shade on the side of 0, 0. So that's why this side gets shaded there. And y is less than or equal to 4x. Well, 4x here goes through the origin. So it's going to go through the origin there, and we can see it'll go through the point 1, 4, because when x is equal to 1, y is equal to 4. It's equal to, so it's a nice solid line. So in this case, we're going to have to test some other point. So whichever one you want. I'm going to test here. I'm going to test the point 1, 0. So if I test 1, 0 there, y is equal to 0, x is equal to 1. So we get 0 less than or equal to 4, which is true, which means this point here, 1, 0, is in the region. So that's why this side of the line is shaded. So we have to do it that way. So there's one where it went through the origin. We have to pick another point. No, that's okay. Pick any point you like. You don't have to pick the origin. You can pick any point you like. Another one where it goes through the origin, because y is equal to 2x, would be that line there again. So it goes through 0, 0. When x is equal to 2, it's 4. When it's 3, it goes through 6. So there's our line there. So, and then we got to test another point. So again, I'll pick 1, 0. It's as easy as any. So I get y is equal to 0, greater than or equal to 2 lots of 1. So we see that 0 is not greater than or equal to 2. So it fails. So that means we have to shade the other side of the line, because 1, 0 doesn't satisfy the region. So we go on the other side of the line. So there's our technique. We go through and we draw our line, see whether it's going to be solid or dashed, then pick a point, test one side or the other of the line, and then make our decision which side we're going to shade, whether the point fails the region or it satisfies the region. Every time we're doing the same thing, if we follow that same rule every time, we shouldn't get too many problems.